Hello students, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today Physi Dive is in front of you with a new topic for class 9 students, that is equations of motion. A sure short question for your exam and a very important topic because you will carry out the same topic to your 11th standard, and if you are continuing with engineering and other technical courses, you will come across with these particular equations. And we are diving straight to the class. So equations of motion, mainly we're just starting this particular topic with a given scenario. Just imagine that you have an object at point A and the object is placed at the origin O. Now you are saying that you are initially seeing that particular object and you are coming to this particular point. The object is moving with an initial velocity u, and the object is moving, and you can see that after some time t the object will reach another point B, and there when you check the velocity of that particular object, then you can see that that object is having a different velocity. So we are saying that the object is having the velocity v, or we call it as final velocity. So definitely the velocity has changed from u to v, so definitely it will have an acceleration a, and the time taken is t. Acceleration a, initial velocity u, final velocity v, and the object has displaced or changed its position from point A to B, and the displacement is given by s. Here comes a scenario. These are the scenarios that you should keep in your mind before studying this particular topic. So summarizing, you can see on the screen. So this is a summary of the scenario that you have seen, and here mainly keep in your mind that this particular scenario happens, or we are dealing with equations of motion with uniformly accelerated motion. The study is conducted for uniformly accelerated object. That's why you are getting a constant a there. Okay, fine. So in this session, we are dealing with three equations, namely which velocity time relation or equation, next displacement time equation, as well as the third equation which gives a clear-cut idea on displacement velocity equation. So we are dealing with three equations of motion, and each equations of motion will give you this particular relation, that is velocity time relation. The first equation which we are studying, that will give you the velocity time relation, and the second equation will give you, or which gives a clear statement or clear cut idea about the displacement time relation, and the third equation which will give you an idea how the displacement and velocity are related. So straight to the equations. Mainly we need to study about three equations, and the first equation goes like this, that is v is equal to u plus at, and the second equation goes like this, that is s is equal to ut plus half at square, and the third equation, that is v square is equal to u square plus 2as. So see, the first equation is having a relation between the velocity and time, and the second equation deals with displacement and time. Time is there. And the third equation which deals with velocity and displacement. Let us move straight, and the first equation goes like this, that is v is equal to u plus at. So how we can derive this v is equal to u plus at? Imagine that an object is there with initial velocity u, and it is moving with an acceleration a, and it is having a final velocity v at time t. After time t, after its initial movement, after time t, you can see that the velocity is v. So how can I calculate the acceleration? Acceleration, by the definition of acceleration is given by, acceleration is equal to rate of change in velocity, or otherwise how can I say rate of change in velocity. Change in velocity, whenever the term comes rate, then that means divided by time. So what is change in velocity? You can see change in velocity is equal to v minus u, y final velocity minus initial velocity divided by time. So acceleration is equal to v minus u by t. From there you rearrange and you will get at is equal to v minus u, and simply v is equal to u plus at. Here comes your first equation of motion, that is v is equal to u plus at. I hope that you understood the point. Now coming to the second equation of motion, where how can I calculate s displacement and the relation with that particular displacement with the time. So I'm just taking the same scenario that you have seen it before, and we need to find out this particular object's movement from position A to B in time t and is having a uniform acceleration a. This is a scenario, right? Now, what is a basic equation of displacement? Displacement is given by basic equation. What is that? Displacement is equal to velocity into time. Here you can see that the object is moving from one point to another and it is having an acceleration, right? So velocity we cannot state or give a particular velocity. Why? Because it is an accelerated motion. I cannot say that the object is moving with 20 meter per second because it is having an acceleration. So I need to take the average velocity. So I'm just taking the average velocity into time. Here comes a new term, average velocity. So average velocity is given by final plus initial divided by 2. The final velocity plus initial velocity divided by 2. Why? I can only take this particular equation if this is a uniformly accelerated motion. If this particular object is non-uniformly accelerated movement, then we cannot take this equation. It is something else that you will study in your 11th standard topic. Now I can say that average velocity is given by v plus u by 2 into time. This is a thing, right? I hope that you got the point. So here, before we have studied that v is equal to u plus at from first equation of motion, right? I am just substituting the value of v here. Why? Because in the equation there is no term v, and I will get s is equal to v. Instead of v, I am just writing u plus at plus u by 2 into t, or simply 2u, and I am just operating this t here inside. So 2ut plus 8t square by 2. I hope that you got the point. Just clearly see that, pause the video and go through that equation. Okay, I'm just taking 2u plus u, that is 2u, and I'm operating this t here inside, so 2ut, and one at is there, and I'm just operating this t to 80, then it is 80 square divided by this 2, as 2 is common for both the terms. Now I'm just seeing just dividing the terms, then 2ut by 2 plus 80 square by 2, that is s. Then you will get s is equal to ut plus half 80 square. I hope that you got the point. How you start? You start from basic equation, that is displacement is equal to velocity into time, and that velocity is average velocity for uniformly accelerated motion. That average velocity is v plus u by 2. The third equation of motion is v square is equal to u square plus 2as. How these velocities and displacement are connected. Now from the second equation we know that s is equal to ut plus half at square, and from the first equation of motion v is equal to u plus at. From the first equation of motion, t is equal to what? T is equal to v minus u by a, right? So I'm just giving you another equation, that is 3. I am substituting this third equation to the second one. Then what will I get? Then I will get s is equal to ut. T is v minus u by a plus half a, sorry, here it is t square. Got it? So a v minus u by a whole square. Got it? Then what will I get? I'm just operating the bracket. Then uv minus u square by a plus 1 square is there. This square is common for both, right? So 1a square will be there, right? Then 1a square and 1a, they will cancel out each other. Then half v minus u the whole square by a. This is the case. Pause the video and see whether you got the point. Got it? Now, from here, s is equal to uv minus u square by a plus v square. V minus u, the whole square is equal to v square plus u square minus 2 uv. So v square plus u square minus 2 uv. Simple mathematical equations. That is 2a. Take the LCM. Then you will get 2uv minus 2u square plus v square plus u square minus 2uv divided by 2a. Then 2uv and minus 2u, they cancel out each other. Then what will you get? v square minus 2u square plus u square is plus u square. Minus 2u square plus u square is equal to minus u square by 2a, that is s. So from there you will get v square minus u square is equal to 2as. From we'll get v square is equal to u square plus 2as, which is nothing but the third equation of motion. But the third equation of motion. Here comes the end of all the three equations of motion, and I hope that you got the point. If you find any difficulties, then pause the video, just make your mind clear, and simple mathematics, you got the idea. If the concept is clear, then use the mathematics and you will get all the three equations correct. So all the three. What are the three equations? First equation of motion is v is equal to u plus at. Second equation, s is equal to ut plus half at square. And the third equation is v square is equal to u square plus 2as. So that's it for today's class. And we'll see in the next class with a variety of topics. And we will deal the same topic graphically. So before that, we need to study the different types of graphs and what are the concepts behind these graphs. And then we will study the same topic, that is equations of motion, once again, and using graphical method. So this is the analog mathematical method, the other one is graphical method. So I hope that you got the points. So that's it. So we need your support. Like, share, comment, as well as subscribe. We'll see you in the next class. Goodbye.